So here is another linear programming problem, and this time it is a minimization problem. The objective function is minimize and not maximize. Now before we formulate the LP problem and solve it, let us first read the problem and understand. A small firm has production facilities for producing two different products A and B. Each of the products requires two different operations, grinding and testing. Product A requires 15 and 15 minutes to grind and test respectively. So 15 minutes to grind and 15 minutes to test. While product B requires 7.5 minutes and 45 minutes to grind and test respectively. The production run calls for at least 7.5 hours of grinding time and at least 15 hours of testing time. If the manufacturing cost of the two products are rupees 60 and 90 respectively, how many units of each product should the firm produce in order to minimize the cost of production? So here this is a minimization problem. So first thing first, let us define the two decision variables. Now there are two decision variables here, product A and product B. So let X and Y be the two products A and B respectively. Okay, the objective function is given by, now this is a minimization problem, so minimize Z is equal to X plus Y. Now how, what is the manufacturing cost of the two products? Now manufacturing cost for product X is 60, so it is 60X, and cost of manufacturing product B is, or Y is 90Y. So we have to minimize this subject to the constraints Okay, now there are two constraints here. One is the grinding time and the other one is the testing time. Now it says here that the production run calls for at least 7.5 hours of grinding time. So at least 7.5 hours. Convert that the hours to minutes. 7.5 hours will be 450 minutes. So the grinding time should be at least 450 minutes, and the testing time is 15 hours. So 15 hours to minutes is 900 minutes. So again, your testing time also should be at least 900 minutes. Now see, this is just the opposite of the maximization problem. In the minimization problem, okay, you see the constraints, the condition is just the opposite. All right, and it says here that product A, that means X, requires 15 minutes of grinding and 15 minutes of testing. So X requires how many? 15 minutes of grinding and 15 minutes of testing. And product B, that means Y, requires 7.5 minutes of grinding and 45 minutes of testing. So 7.5 minutes of grinding time and 45 minutes of testing time. X be equal to or greater than 0, Y is also equal to or greater than 0. These are non-negative constraints. Remember that the decision variables cannot be negative. They can either be 0 or more. Alright, now let us solve. So we've already formulated the problem. Now let us solve this problem using the graphical method. So first things first is we have to convert. Okay, so convert the inequalities to equalities and find the divisibles of the equalities. Alright, so you have two inequalities here, 15x plus 7.5y. Convert that to an equality. Find out the coordinates. So x will be 450 divided by 15. So that will be 30. And y will be 450 divided by 7.5. You'll get 60. And next one is 15x plus 45y equal to 900. So x is 900 divided by 15. That will be 60. Y 900 divided by divided by 45. You'll get 20. So there we found out the coordinates. Now let us plot them on a graph. Okay, so this will be 5, 10, 20, 25, 30, 35, 40, 45, 50. Wait, I made a mistake. 5, 10, 15. Oh shoot. Sorry about that, I had to go looking for an eraser. Alright, so 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Alright, same thing for, so this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55 and 60. Okay, this is the highest number, 60, so we leave it at 60. So this is your y-axis and your x-axis. Now let us plot the coordinates. X is 30, y is 60. So x is 30, y is 60. there you have it. So we are done with the first one. Second one is x is 60, y is 20. X is 60, y is 20. Okay, there we have it. So this is your 15x plus 7.5y equal to or greater than 450. That's your first constraint. And this is your second constraint. 15x plus 45y equal to or greater than 900. Okay, now remember that this is a minimization problem. So the feasible region in a minimization problem is opposite that of the maximization problem. In a maximization problem, would be your feasible region closer to the origin. All right, but in a minimization problem, your feasible region should be away from the origin. So this would be your feasible region. And your extreme corners, your extreme points are these, not these. These are your extreme points. 1, 2, and 3. So let's call this A and say this is B and this one is C. Alright, now let's find out the coordinates of the extreme corners or the extreme points, and also find out the value by substituting those coordinates in the objective function. Okay, so extreme points, your coordinates, and your objective function. What is your objective function? Objective function is minimize z. Okay, minimize z or z. Okay, equal to 60x plus 90y. Okay, 60x plus 90y. Now what are your extreme points here? Your extreme points are A, B, and C. Now what are the coordinates of A? A will be 60, 0, and B it'll be say 24 and 12. Okay, it may change if you use a proper a graph paper. Maybe it may be 24.5 or 13. Okay, but it doesn't matter. And C is 0, 60. 0, 60. Okay, now substitute these coordinates in the objective function. Z is equal to 60x, which is 60, plus 90y, which is 0. So this will be 0, this will be 6636, so there will be 3600. Okay, next z is equal to 60 into 24 plus 90 into 12 will be equal to, this will be 1440 into 1080 equals to 2520. The third one is 60 0 plus 90 into 60, 6 9 6 is 54, so this will be 5400. Now remember, this is a minimization problem. So how many So how much of product X and how much of product Y are you going to produce? Now, since your objective function is to minimize the cost, and your cost will be minimized at which extreme point, A, B, or C? Yes, it'll be minimized at extreme point B, where the value of X is 24 and the value of Y is 12. So therefore, since the objective is to minimize the cost of production, the firm should produce 24 of product A, which is in this case it is X, and 12 of product B. In this case it is Y. Alright, so it is 24, should be 24 units. It's given 24 units of product A and 12 units of product Y. So this is how you solve a minimization problem. You first formulate, then solve,